Question 1 says Talia recorded how long it took her to run 400 meters in each of her last 8 races. Her times, rounded to the nearest tenth of a second, are listed below. What is the median in seconds of Talia's time? Now remember that word median means middle. So to find the median, we need to list our numbers from least to greatest. I usually like to cross mine off as I'm listing from least to greatest just to make sure I don't skip anything, and it helps me to catch any potential mistakes. Once I have my list from least to greatest, I just need to find the number in the middle. So I can go ahead and cross off my numbers on each side, left, right, left, right, left, right, and I end up with 60 and 60.2 in the middle. Now remember that when I have two numbers left over, I can either find the halfway point between those numbers, or I can add them up and divide by 2. My answer in this case will be 60.1. Question 2 says the points scored by a football team are shown in the stem and leaf plot below. Now remember that a stem and leaf plot is just a fancy way of displaying numbers. This number is 6, this one's 12, 13, 14, 17, because these numbers on the left are the tens place. So if I'm looking for the median, what was the median number of points scored by the football team? I'm just looking for the middle number in my list. The great thing about a stem and leaf plot is my numbers are already listed from least to greatest, so I can simply cross them off. Left, right, left, right, left, right, until I end up with my middle number. And in this case, both numbers in the middle are these two 4s, but these 4s represent 24 since the number that's in the tens place is a 2. And my final answer is 24. Question 3 says, Vi asked 200 students to select their favorite sport and record the results in the bar graph below. Vi will ask another 80 students to select their favorite sport. Based on the information in the bar graph, how many more students of the next 80 are likely to select basketball rather than football as their favorite sport? So we know that she asked 200 students to select their favorite sport to start. And out of those 200 students, about 75, maybe 72-ish chose basketball. So we know that 72 out of 200 students chose basketball. And I can find the percent. 72 out of 200, I can divide. 72 divided by 200 is about 0.31, which equals 31%. Now, I know that she's asking another 80 students to select their favorite sport. And the question is that if in her survey about 31% have been saying that they prefer basketball, how many of the next 80 will say the same? So, what is 31% of 80? I'm going to multiply 80 times 0.31. And 80 times 0.31 is equal to 24.8. But remember that your answer shouldn't be exactly correct because we had to make an estimation here of exactly how tall this bar was. But I can see that 24.8 is pretty close to 25. And so I know that that is the best estimation for this answer. The next question says, the daily high temperature in degrees Fahrenheit of a town are recorded for 1 year. The median high temperature is 62 degrees Fahrenheit, and the interquartile range of high temperatures is 32. Which statement is most likely true? So, remember that the interquartile range represents the percentages of the data. So if we know that the median high temperature is 62 degrees Fahrenheit, the interquartile range of the high temperatures is 32, which means that the median is at 62, and if you can imagine the interquartile range of a box plot, it is 32 degrees wide, right? And we don't know exactly where it starts and finishes, but we know it's 32 degrees wide. So the first answer says approximately 25% of the days had a high temperature less than 30. Now, we don't know that because you could have a very high collection of data points between 62 and Q1. Maybe there's a ton of data points right at 60, and then Q1 might be much higher than 30 degrees Fahrenheit. So A is not true. B says 25% of the days had a high temperature greater than 62. Well, 62 is the median, so we know that there's way more than 25% of the data past the median because the median is the 50 percentile mark of the data, right? 62 is the 50th percentile. B says approximately 50% of the days had a high temperature greater than 62. Well, on first glance, C makes a lot of sense because, like I just said, 60 is the median, and we know that the median splits the data in half. So C looks good, but let's make sure that D is also incorrect. D says 75% of the days had a high temperature less than 94. Well, we know that that's wrong for the same reason A is wrong, or potentially wrong, I should say, because it's possible that 62 is the median and Q1 could be 64. There could just be a ton of data points here between 62 and 64, and then maybe the maximum is even less than 94. So we just don't know what Q3 is or what the maximum and minimum are based on the information that's been given. All right, so question 5 says the daily high temperatures in degrees Fahrenheit in Allentown, PA for a period of 10 days are shown below, and it says which statement correctly describes the data. So it looks like we're going to need to find the IQR in order for us to do this correctly. So let's just go ahead and get started. We've got to list our data from least to greatest: 76, 80, 82. Sometimes you might be able to use process of elimination before, skipping straight to having to calculate the 5-number summary. But in this case, we've just got to go ahead and do the 5-number summary. We won't be able to answer the question without it. All right, so we want to find the median. The median's the middle number. We know we have 10 days. So we know that the median is going to fall right between day 5 and 6. So we know the median is 90. And we know that Q1 will be the middle of the bottom half. And we know that Q2 will be the middle of the upper half, or Q3, I should say. So then we know that the IQR is Q3 minus Q1, so 18 minus 82, 16. All right, let's see what our options are. So the median is not 98. The lower quartile is not 76. The minimum is 76, but the lower quartile is 82. The interquartile range is 16. That's true. Let's just make sure D is incorrect. The upper quartile is 96. No, it's 98. So we know D is our correct answer. All right, Javier's score on a science test is equal to the upper quartile of all the scores in the test. Based on this information, which statement about Javier's score is most likely to be true? Well, let's just think about what we know about kind of the 5-number summary. Just generally, right? We know that the median is the number that's in the middle. We've got Q1, we've got Q3, and we've got a minimum and a maximum. Now remember that we've talked about how the data from the minimum to the median, that's 50% of the data. And the data from Q3 to the max, or from the median to the maximum, is 50%. And then what we do is we split up the data more. We have 25% of the data from Q1 to the minimum, another 25% from Q1 to the median to Q3 is another 25%, and Q3 to the maximum is another 25%. So we don't know what his score is. We don't know about A. We don't know what his score is. We really have no idea. We also don't know how many scores there are. So when it says it's greater than 75 other scores, well, we don't know how many kids took the test. So we don't know B. C says his score is the same as 75% of the other scores. Well, remember, all we know is that his score is Q3. Javier scored Q3. So it wouldn't make sense to say that his score is the same as 75% of the other scores. But it is greater than 75% of the other scores because Q3 is greater than these three groups of 25%, which we can also think of as 75%. And so Javier's score is greater than 75% of the other scores. All right, question 7 says the cast of a play put out 12 performances. They sold more tickets for each performance than they sold for the performance immediately before it. The box and whisker plot below shows some information about the number of tickets sold for each performance. So for their first 3 performances, the cast sold 112, 114, and 116 tickets. How many tickets did they sell for their 4th performance? Well, we know that they put on 12 performances, right? And we know that for the first 3, they sold 12, 114, and 116. So we also know that they sold more tickets for each performance than they sold for the performance immediately before it. So meaning that they sold 112, 114, and 116. So the 4th performance is definitely more than 112, 114, and 116. So let's see what we know about the bar chart here, or I should say about the box plot. We can see 112 is the minimum, and we can see that Q1 is 118. Q1 is 118. Now we know in this case that Q1 is going to be the average of the 3rd and 4th data point. And let me explain why. We have 12 data points. I'm just going to draw them as dots. So our median will be between the 6th number and the 7th number if the numbers are listed from least to greatest, right? We know what these first 3 data points are. We know that they're 112, 114, and 116. We also know that Q1 is 118 because we see it right here on the graph, right? So we know that whatever this 4th data point is, 116 plus that data point divided by 2 is equal to 118. And we have 4 numbers to guess and check from. You could also multiply both sides by 2 and subtract 116, but the answer is 120. And the reason why is because if 120 is this 4th data point here, we end up with 116 plus 120, which equals Q1 of 118. All right, question 8 says a data set is shown below. What's the first quartile value of the data set? Looks like we got lucky and they listed it from least to greatest for us. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. So we know that the median will be between 5 and 6. And we know that Q1 will be the median of the lower half, which is 111. Question 9 says the circle graph below shows the percent of the total number of students enrolled in a high school who are in each grade. There are currently 448 freshmen enrolled in the school, and about 75% of the seniors enrolled will attend college next year. What is the most likely number of seniors enrolled in high school who will attend college next year? Okay, so we know that there are 448 freshmen. And so 448 is 28% of some number. We know that 448 is 28% of something, and we can find that by dividing 448 divided by 0.28. So I'm going to go ahead and divide that. It equals 1,600. Now that's the total number of students, 1,600. And I know that 24% of the school is seniors. So 24% of 1,600 is 1,600 times 0.24. And that gives me a total of 384 seniors. But remember that 75% of those seniors will attend college. And so if I know that there are 384 seniors, I need to multiply that number times 0.75. And that will tell me the total number of seniors who are attending college, which is 288. 288 seniors attending college. All right, question 10 says, Derek did yard work for 12 weeks last summer to learn extra money. He earned $12 an hour, and he worked a different number of hours each week. He recorded the number of hours he worked each week and used the data to make the box and whisker plot shown below. So, hours that Derek worked each week last summer. The question is, how many of the 12 weeks last summer did Derek earn more than $192? Well, to earn $192, Derek would need to work 192 divided by $12 per hour. And 192 divided by 12 is equal to 16 hours. So we know that when Derek worked 16 hours, that's when he made more than $192. So we see 16 represents Q3 on the graph, which means that 25% of the data is greater than 16. Because there were 12 weeks last summer in total, we know that whatever 25% of those 12 weeks is how many weeks he made more than $192. And you could do the math. You could just multiply 12 times 0.25, or you might just know in your head that a fourth or a quarter of 12 is equal to 3. So he earned more than $192 for 3 weeks. All right, this last question was extra credit. It said a soccer coach recorded how many hours, rounded to the nearest hour, each of 12 soccer players practiced for last week. The first quartile of the data was 7.5. Which statement must be true? So we know that there are 12 soccer players in total. And we know that the first quartile of the data is 7.5, which means that 25%, the 25th percentile of the data, the Q1, is 7.5. It always helps me to kind of draw out the box plot just so I can imagine what's happening. So remember that Q1, just like I drew out before, the last time we had 12 data points up here for this question, Q1 will be between the third and fourth data point, right? Because it's the median of the lower half. So it's not true that exactly 3 out of 12 players practiced for at least 7.5 hours last week, because some of them could have practiced less. It's also not true that they necessarily practiced between 7 and 8 hours last week, because we don't know for how long they practiced. It's not true that 9 of the 12 soccer players practiced for at least 7.5 hours this week, because it's possible that more than that practiced at least 7.5 hours this week. Imagine if the data set looked like this: 7.5, 7.5, 7.5, 7.5. 7.5. If these were the first 6 numbers, Q1 would still be 7.5, but more than 9 soccer players would have practiced 7.5 hours. And then D says 9 out of the 12 soccer players practice between 7 and 8 hours, and we just don't know about that 8 hours piece. So I accidentally eliminated a correct answer. Can you guys tell which one it is? It's A. It's A. And the reason why is this. We know that Q1 is 7.5, which means that all of these 3 players, these 3 players here,